Here we are, ready to go. I'm so scared. Hey everyone, welcome back. We're doing a video now that likely should have been done 8 videos ago. It's going to be all about the jet. I'm going to talk to you about its history, where it came from, how I got it, what it did in its previous life, and then I'll go through all the components. I've got a breakout sheet of it, so we're going to go through and learn all about this 1984, I think it was built, 1984, PZL SO-3 Polish-made turbojet engine. It's awesome. Anyway, so I've got the Wikipedia information on this, which shockingly there isn't a whole lot of info on. It's a PZL for the rest of us Canadians, I suppose. Rezo, I'll put the spelling up on the screen here, I can't pronounce that. SO-3. So what this actually is, it's a Polish-made engine. It's derived from the English, it was a Bristol Siddeley or Siddeley Bristol Viper 8. So from what I've read on a deep dive on the internet, Lithuania had the engine, a Viper 8, and somehow Poland got a hold of it, they reverse engineered it, and then they designed this thing. It does have slightly higher thrust rating than what the Viper 8 had. We'll get into that in a little bit. But if you look at cutaway drawings and just the way things operate, they're extremely similar, extremely similar. So it was originally started as, what was it? It was the WO10, I believe, was the prototype. Then they made the SO-1, and this is designed for their single-engine jet trainer, the TS-11 Iskra. Apologies, had an actual work call coming in, paying the bills for this. Where did I leave off? So this was originally designed for Polish TS-11 Iskra. I'll show you a picture here. And this was derived, it started as a WO10 as a prototype. The SO-1 was developed, and they only made a handful of them, and then the SO-3. So the SO-3, they had 500 and some odd examples made of that. 580 were built, and then shortly after that, which I don't really know the history too well on, is the SO-3W. They call the W is the big guy. It's got a couple hundred pounds more thrust, and that's what a lot of the current 2025, 2026 jets are after. So when they need to upgrade their SO-3 for whatever reason, they look for the W. Or they go to a whole new platform like a JD5 or something. But the SO-3W is the big one. This is just the regular SO-3. Again, it was designed for the TS-11 Iskra. It's a Polish jet trainer, and I believe India had a variant of that as well. So not too common, but yeah. First run, November 1968. Like I said, this example, we'll look at the nameplate on the other side, but I believe this one's built in 1980, 84 or 86. But it was first run in 1968, so no electronic control. Everything is mechanical, springs, valves, bellows, levers, that sort of thing for it to run, which is, for me, is fantastic. It's 85 inches long, diameter of 28 inches, and it weighs 700 pounds dry. So without oil in it, as assembled as just the engine portion, not the airframe, it's just a little over 700 pounds. We'll get to it. 7-stage all-steel axial compressor. Annular combustor with 24, it says 24 combustors, but it's an annular combustor is just one big donut looking thing. That's as opposed to like a cans mounted around in a circle. And it's got a single stage turbine. axial flow turbine. Maximum thrust takeoff rate is 2,400 pounds, continuous is 2,200 pounds coming out the back. I'm guessing it's a little tired, so it might be making a little bit less, but that's nominally what it's rated for. Thrust to weight ratio 3.4, which is standard. That's pretty much all that Wikipedia has on it. There's really not a whole lot to it. So this example in particular came out of, what was it, November? I'll put a picture up with the tail number. It came out of an Iskra that did some of the Reno air races, and it crashed mysteriously. I talked to the guy I got this from. We did a deep dive, could not find an accident report on the aircraft that this specific engine was in. But it crashed in the 2010 timeframe, and then it sat for a while. There's pictures of it in Colorado. Wings off, in total disrepair. The aircraft in total disrepair. And then a fella down in Tennessee bought it, and I got in touch with him, and we made a deal, and I drove down to Tennessee with a good friend to pick it up. And actually that's where the channel's thumbnail picture comes from. Excited to get my first thrust jet engine, and brought it back, and we'll see if there's some B-roll pictures and photos, pictures and videos we'll throw up here. When I first got it, I didn't think of YouTube, at the time I got it, and didn't act on it. So here's some stuff. All right, without further ado, here we go. Oh, I'm so scared. Yeah, we got it running. I built a test stand for it. We sat it in there, hooked some power to it, ran the starter, make sure that worked. Figuring it out. One of the deals that I got with it that sort of had to be a part of the deal was a manual, an operation and description manual. It's a 500-page manual. It's paper version. So I ended up taking it with me. I scanned every single page, mailed it back to the original guy because he has a couple of these Iskra aircraft, so he'd like to have a copy of the manual. So I do have a full digital copy of the service and operating manual of the engine. No overhaul, just service and operation, which has been invaluable. You can't begin to understand these engines without a manual or something to tell you what they require. They're all the same, but they're all different. And we can get to the sequence later, but here's an example of they're all the same, they're all different. Starting sequence. Every single person I talk to in the aviation world, not in the aviation world, say get N2, get engine RPM up to a sufficient speed before introducing fuel. This thing, fuel comes on as soon as you hit the start button. So it's designed to light off in the first couple seconds of spinning. That's in the manual. It's written in a few spots. It's true, believe it, but there's one of the differences. During our recent starting issues, that played a factor and played a role in why we couldn't get this thing to light, even though it did before. So let's take a tour. We'll go through the engine front to back, what's what, what the ratings are, what the specs are, what I know so far. Yeah, this thing's awesome. Actually, let's go to the office first and we can look at a cutaway drawing of the engine, of the complete engine, and then we'll come out here to have a look and compare notes. All right, here we have a nice, beautiful cutaway drawing of the SO-3 turbojet. So I just want to go over some of the components, get familiar with how it's constructed. Very, very similar, like I said, to that Viper 8. So the Viper is a series of engines designed and built by Rolls-Royce and or Bristol Bristol, designed and built by Rolls-Royce. Yeah, so this is a copy. So what we have here at the beginning on the left, airflow is this way through the engine. So this would be the front. So we have our combination starter generator. So this is an electric motor. It uses 28 volts DC to get it get the engine rotating. And once it's running and up to speed, this converts over to a generator. I think it's like a 6 kilowatt or something output generator. So then it's producing electricity for the aircraft. The instruments and everything, the engine doesn't need any electronic support once it's, or electric support once it's running. So then we come through, we have our, just a radial drive shaft, I think they call it. So main shaft of the rotor runs through here. There's a gearbox on here that powers a shaft that powers all the accessories down here. So down in this area, it's not all shown, but we have an oil pump, a hydraulic pump, a high pressure fuel pump, which is actually this guy right there. On this side, we have a tach generator. So it's what provides a signal to the RPM gauge in the aircraft to tell the pilot what the RPM of the engine is. I think that's it on the accessory drive. Then as we come through here, we have a front main bearing, which I believe is right here. Each one of, this would be your inlet guide, call it inlet guide vane. It's the inlet to the compressor. So it's this great big nozzle, this great big blade, I suppose. This next one is a part of, as you can see, it's designed, it's a part of the compressor. So this rotates. This is stationary, this rotates, stationary, rotates, etc. There's 7 stages of each. So let's say we have 1, 2, 3, 4, 5, 6, 7. So this would be the last stator. It's a stationary blade before it goes into the combustor. I'm not going to pretend that I know every single minute detail of this engine. I know enough to be dangerous. How's that? Just going to walk around the tripod here. This would be your oil feeds. So we've got oil into our center bearing, and then oil coming back to our rear bearing. So this produces, I think it's about 40 psi of air through here, which is pretty low by today's standards. It might be a bit higher actually, but it's not much higher. So through these 7 stages, it produces a pressure above ambient or above atmospheric, and that diverges in this duct, which means it slows the air down. Have the air comes in through here. You can see this is our one of our main fuel nozzles. Then we also have starting in the same ring. This would be an example of an atomizer, a starting atomizer. So the air is going to come through. Some is going to go through the annular combustor. So this is like that cheese grater looking annular combustor. It wraps all the way around the motor, around the engine, sorry. So flame propagation and everything happens as like a donut, like a ring. So some air comes inside and some sort of bleeds in to cool as it's passing over. So we have our starting atomizers here. That gets the fuel going. The igniter, this would be an example of an igniter. Remember from some of our previous videos, there's 2 of them on the aircraft, or on the engine, sorry. And then once the flame is propagated with the atomizer, usually within a few seconds, then our main fuel comes on. There's 12 of these vaporizers, they call them. And then that will create the larger flame, and that is controlled by our fuel control unit, which we're not going to get into here. I think this is a locating pin. There's only a couple of them around the combustor, and that's for locating the annular combustor liner. This is an example of the, I think it's the fire suppression ring that was around it. This looks like could be compressor discharge is what it's representing. Yeah, then fire and flame come all the way back. We want to get the temperatures not as low as we can, but get it down so that when it hits the turbine, which is this right here, the rotating piece, it's cool enough to handle it. So this would be a turbine nozzle, turbine stator. I don't know if I'm saying that right. So this is stationary right here, and it kind of helps direct the air into the turbine, which has a turn blade. Actually, hey, let me show you. I've got some examples from a friend of ours. Check that out. A friend of ours had these little 3D printed things made up for some blades that our friend Agent JZ, who rebuilds these J79s and Arenda 10s and 14s and whatnot, sent us some spare blades. So this would be, I believe, second and third stage J79 turbine, and this is 7th? 14, somewhere. It's one of the 17 stages or whatever of a J79 compressor blade. So there's a little bit of a difference here. Anyways, this rotating piece here is a turbine blade, and this is what they look like. So the fixed stator, the fixed nozzle there, helps direct air into this guy, which rotates around as required. So then it comes through, it comes into the propelling nozzle. If this was just wide open, it'd be a little bit windy, but nothing crazy. But this converging duct here is what creates all that thrust from the expanding hot gases coming out. And this is just, what do they call it? People call them bishop's hat, just to help keep a nice smooth, air likes all nice smooth transitions, right? So this keeps it nice and smooth. And then of course our EGT thermocouples are mounted roughly in this area here, and there's 4 of them that go around. Which that's not it. So this is a strut. So there's 3 of these around the engine, and they essentially keep everything straight in the back and supported. So the thermocouples are probably represented about there, going around. Struts at the front. So we've got 3 struts around here. The drive shaft runs through 1. Up on this side, we have the electrical connections for the starter, and on the other side, oil comes in to oil that front bearing. So now that you've seen the cutaway version, sorry, these are drains. Drains for the combustor case. So when we shut fuel off, flame stops, but there's still some residual fuel in the system, and it drains out here. One out of the combustor, and the other, it looks like it comes out of the tail cone area. So let's go out to the jet and see if we can make sense of what's what out there. All right, let's look at the front of this engine here. So we have, let's get rid of this light here. The lighting isn't the best. I do apologize for that. I'm not sure where my light went, so we'll make do with what we've got here. This is a FOD screen, foreign object debris. It keeps all of that foreign object and debris from foreign object damaging my engine. So I made this at a 1/2-inch EMT. As an electrician, I found bending it a little bit easy. Then we put it together, welded it, and put this little screen on it. It's the first rendition, so I'm sure the next one will be that much better. Next is a bell mouth. So it's a radius inlet to the engine. It is hard to see with that FOD screen on. Let's see if we can zoom out a little bit here. Oh, wrong way. So that creates a nice turn for the air to get in. So I made that again, first rendition. I'm sure the next attempt will be that much better. So there's that massive starter generator, it's about as big as my hand. If I could get my hand in there, you'd be able to see that. You see the size of it. And then farther in, so we can see the struts. One there, and there's one at the bottom. Then our first series of blades are fixed, and then the compressor is right behind it. 7-stage all steel axial compressor. Okay, so we'll move on to the left side here. So one of the struts at the front, like I said, runs a radial drive shaft, and it runs this. So this is our this is our oil reservoir. The oil pump, well, this is more like a gear case. Not really a reservoir, but this is a gear case. So the radial drive shaft comes down, and then there's a whole bunch of gears to run a whole bunch of other things. One of which is the tach generator. This is what provides the RPM signal to the gauge. We've got the, you can't really see under here, high pressure fuel pumps back there. And the other side is the oil pump, and behind the oil pump is the hydraulic pump. Okay, the other strut runs the electrical for that starter generator. So we have our, what do we have here? One's a ground, one's a positive to start, and the other is an output from the generator, which we're not using. And this is for the shunt field winding. So that's controlled by a relay on the other side. We'll start with this line here measures oil pressure. We'll start up here. This is the fuel flow control unit. We've seen in other videos I've kind of randomly gone between some components depending on what we're troubleshooting. But let's look at, we won't get much into the car, but let's start here. Here's a fuel filter. Fuel comes into here around this loop. The loop's not there for any particular reason. I just didn't want to cut the hose. This is our primary engine fuel filter. Well, really it's our only fuel filter, the rest are screens. From the filter, fuel comes in and it goes through this large pipe here and feeds the high pressure fuel pump. Manual spec on startup is it needs 21 psi. It's all measured in cubic centimeters per kilogram. Kilogram per cubic centimeter, something like that. Anyways, that converts to about 21 psi plus minus 7 psi. So it goes in there, and then from there, this happens. No, it comes up, it goes through this feed pipe up here, which tees off to, I've added these gauges, they're not factory, and I've welded in some AN fittings because the fittings that they use from the factory in Poland, we can't really get over here. They're really not readily available. So that's why you see some of this goofy stuff added to it. But it tees off here. This is called the corrector. We'll get to it when we get to the other side of the car. But it will bleed off fuel depending on the altitude. I'm not saying that right. It will not allow the engine to increase or decrease RPM with the change in altitude. So it sort of compensates for that change in atmospheric pressure. So whatever doesn't get bled off comes through here. There's a screen in here. This is an idle adjustment, and it comes in the fuel flow control unit. So from there, we've got our throttle up here and our fuel shutoff cock here. So this is our fuel on off. This is our, obviously our go pedal, and they are all in the off position currently. So throttle down and fuel off. There's a lot of little bleed things that happen in here. Inside is all, you know, springs and diaphragms and bellows and that sort of magic. From here, it comes down through this pipe to the air-fuel ratio control unit. And what this thing does is it will limit acceleration and the amount of fuel that the engine gets based on compressor discharge. So this hose or this line is compressor discharge, but this is an anti-icing to keep this from freezing. The one underneath is a compressor discharge, and that's what this unit references for basically when you can and can't accelerate and how much and all that. And one of the issues I did have early on does have to do with this. So this, I believe, is slightly damaged, but for what we're using it for, I think it works all right. This other line here is it's called stagnation. pressure, I think. It's a line that goes into here, into the strut, and there's a little hole. So it's going to, through whatever calculation it uses, it's going to take the air pressure that's coming into the engine, compare it to what's at the compressor, and do whatever it has to do. From the air-fuel ratio control unit, we've got our starting fuel manifold here and our running fuel manifold here, and this is something we've been fighting for a little bit, and still not quite done, but understanding it more. Let's come up here. So we'll see this is our altitude corrector. This here is the starting fuel circuit solenoid. So when fuel comes on, this opens up. The engine starts to rotate. We're going to start building pressure through here, and this goes through our starting fuel manifold, which goes to these guys here. There's 6 atomizers. Up here is called the overflow valve. So what it's used for on startup is it bleeds off fuel on a predetermined schedule. So it's timed, and it will bleed fuel from here, the fuel control unit, through here, and then dumps it back onto this side, which is teed in to the return of the fuel filter. Right here is your main fuel running solenoid, or sorry, main fuel circuit, and it ties into this manifold and runs to 12 of these fuel vaporizers, and that's what runs the engine. After the start timer times out, the starting solenoid closes. At the same time, the igniters come off, starter disengages, that sort of thing. This is your compressor discharge. I will call it a manifold. We'll get to the other side. Actually, we'll talk more about that on the other side. There used to be a firewall here, so in the event of a fire happening back here, it will prevent it from coming forward. So it was molded to the inner, I guess, fairing of the aircraft. And then, of course, in here there were temperature sensors that would trigger a fire ring to initiate a fire suppressant. Actually, this is what I've made of it right now. It's got just a pipe with a bunch of holes in it, and all it does is shoot a fire suppressant out. Coming back further, we get into our turbine is right here. Sorry, let's back up here. Our front case, or our front, what is that called? Our front, so our front fixture is right here. This is what the strut goes into, or struts are tied into. Then it bolts to our compressor case. So between here and here, this is all your compressor section. So there are 7 stages of compression are right here. Here's where it transitions into the combustion chamber. It's not really a chamber, it's we'll call it the combustion area. This is where air meets spark meets fuel. Here's where all the fire happens. Your turbine is right here. And that plane there, that's why when it's running, especially when we start to power up and everything, we don't hang around this section here. So typically when these things are rotating, something lets go, they're going to go in the plane of rotation. So that way and that way, or that way. Here's a heat shield around the exhaust nozzle. This little piece here is just because the most sensitive and because the most important and critical part of a gas turbine engine is temperature in the exhaust, I guess the turbine temperature. I've never really trusted these fully, these EGT. I mean, it's 50 years old, the EGT, the thermocouples and the EGT gauge. So I put a known good probe into here just for startup, because once we start putting thrust through it, it bends the probe and doesn't really work anymore. But this is just for now until we get a new electronic EGT monitoring system. In the back, we'll see, I've seen this shot before. That's our turbine disc with all the blades, which look healthy to me. Our thermocouples, and then our struts. These little pieces here, from what I've been reading, you can take them out, and that's what helps, or not take them out, but adjust them, and that's kind of what's determining thrust, because it's reducing the opening, accelerating the gas. Yeah, everything looks good back here to me. Okay, let's start at the front on the right side. So what we've got here is a lot of electronics. Normally this stuff is all mounted in the aircraft, but because I kind of wanted everything together, I put it all here. So this is just a quick, I'm going to redo this when we do our next project that I'll tell you about later. I'm going to redo this, but this is all the electronic controls to make our control panel work with the engine. So it's all mounted in here, an old 50 amp spa pack. This is, sorry, I keep hitting the mount for this camera here. This is the Start SP1 basically start box. So this is a set of contactors. So what used to be between here and here was a squiggly little resistor, starting resistor. Well, I melted that the other day. Oops. So from a friend, I got this giant resistor. And what that's doing is creating a voltage drop on startup, so that when you hit the start button and the contactor comes in, the starter doesn't see full voltage because you can fry it. The starter gives it about half voltage, so it can just start rotating. Once it starts rotating, it starts creating its own field where you can introduce more voltage, and it's easier on the starter. So that's why this is exposed right now, because this was just temporary. It's always temporary. So this contactor comes in first, battery voltage, or I guess starter applied voltage, so 28 volts comes through here, through this resistor, and then back up to here, which is tied to this post here, which goes to the starter. After a couple seconds, a predetermined time in the program, this contactor closes, applying full 28 volts to the starter, and away she goes. And then this disengages whenever it's kind of irrelevant, because the voltage is going to go this way when it's available, not all the way around through the resistor. These here are your igniter boxes, one for each igniter. Some of the Rolls-Royce and fancier engines have one box per two igniters, but this has two, usually for redundancy, but speaking to some of the folks who are former engineers on this thing, say you need to have two. I've never tried starting it with just one, but be interested in doing that. The nameplate I've buried, so you can't really see it. Here, I'm going to put a picture up of a nameplate, whether it's this one or not, I don't know. But we can see this gives you all the relevant information that you need. SO-3, the year it was made, serial, etc. This here is your oil reservoir. So we got our dipstick here. It's turbine oil is typically very, very clean. You can kind of see the shimmer in the light. Anyways, these do consume a little bit of oil, not a whole lot with what we're running, but a little bit. So this is our oil reservoir. Getting back to the compressor discharge air, I believe that this would be a test port right here, but I believe this was the main line that ran to the cockpit. So that would provide environmental stuff, so your heating and air conditioning, and whatever else you would need compressed air for at the front. There's a line down here as well. I believe that was a test port. Right now what I'm using this for is to keep pressure in our fuel tank while it's running. So we'll go up there and quickly talk about fuel supply. Here, this is all, because it's an annular sort of setup, everything on this side is the same as that. Here's our main engine mount. All the thrust that the engine makes comes off of this mount and the other side. So one on each side. This here is only supporting the front. And I can hold the starter and it's, I don't know, 30 pounds, maybe 40 pounds of weight. Not a whole lot, so this doesn't hold a heck of a lot. All the thrust comes from here. Yeah, and coming back on this side, it's the same thing. All right, fuel. Here's our control panel. If we're talking about the jet, we might as well talk about the control panel. So this is original to an aircraft, an Iskra aircraft, not necessarily the one that this engine came from, because I think that aircraft cockpit was pretty well stripped. This is our EGT gauge. This is our RPM gauge. So this gauge runs in conjunction with. So this runs in conjunction with the tach generator to give us our RPM. And this is so laggy, I just don't trust it. Then we have, of course, we have our master on. I can cut ignition and fuel, our e-stop, starter, etc. So our throttle, we only use one set. This is our throttle control. This is our fuel shut off. But if and when we put a twin engine setup, we're already set for dual throttle, dual shut off. So what we do with this tank, this is our fuel tank. It's a 26-gallon air compressor tank. There's a couple videos before of reworking the fuel system. A lot of the stuff is still in here, but we're running into issues with pumps, maintaining the duration, the flow, and anyways, we're trying to do everything on a budget, right? So big shout out to Ryan at Insanity Jet Car out in Alberta, Canada. He really helped me through this. Take an air compressor tank and we pressurize it to about 25 psi. It's slightly above the middle of the road recommended pressure that this engine requires on startup for applied pressure. So we have a Schrader valve right here. I just put a little battery operated compressor onto here. And it doesn't take long because when we fill jet fuel, we get it to just below this part. Right, it's hard to see, but this tank is on a bit of an angle. Not ideal, it's just the way it is. So there's not a lot of gap to fill with air. So we pressurize that. We have a gauge here on the regulator. And we also have a pressure gauge over here to help verify that, hey, we are at 25 pounds or whatever we want. Once that's stopped, we can open up this valve. I'll get to that valve in a second. So this tank is now pressurized. There's a pressure relief valve at 30 psi. It's very, very low, but at least we won't worry about overpressurizing the tank. The tank, it's used to 150 psi, so we're well within a safety margin. That pressurized system comes out here through a ball valve, around into this filter, and then off to the engine to some more filters. So there's three filters before it actually hits the engine. Now that's fine and dandy. We've got our pressure built, but as the engine's consuming fuel, that pressure is going to deteriorate. It's going to go down. So what this giant thing is an air compressor. So we're taking some of that compressor discharge pressure from the environmental setup, going through this hose through a check valve. The check valve's there so that when this is pressurized, the tank, it doesn't backfeed and drain itself into the combustion chamber, the combustor of the engine. It prevents the air from escaping, so once this pressure overcomes this pressure, then it'll start filling the tank. This regulator maintains about 15 psi, 10 to 15 psi during running, because the engine will produce about 40, and we don't want that. So it works tremendously well. I am astounded at how easy it is, how cost effective it is, and just how consistent the pressure is. This thing just makes a whole ton of air pressure, and the volume. Well, think about I had the numbers of 40 pounds per second of air runs through this thing. Measure a pound of air. 40 pounds of air. That sounds like a lot. I don't even know how to quantify that, really. But anyways, here is my little turbojet engine that makes a shocking amount of chaos, thunder, Thor. You see that project behind me? That's going to be coming up next. One of the interesting factors on this engine, or things on this engine, is the starting sequence, and it's timed. So this is 1960s technology. This is before any timing relays, electronics, anything like that. So they use this. It's called an MP1 box. And inside, it's old. We've got this is factory stuff from the aircraft. So it's got an electric motor that turns this gear here, and this gear ends up, it's hard to see, there's a camshaft that runs through the length of this. And it's just like the camshaft in a car where it's got different lobes at different intervals, which as they rotate up, it actuates a lever on a switch, which will turn things on and off as required. So we got cam 1, 2, 3, and 4. I tried hooking this up to the start. Something's bound up, it's not working. So what I ended up doing is I replaced this entire old complicated box with, pardon the mess, but this. It's a timing relay. It's a four position, 4 contact relay, programmable on off. So this reliably runs my starting sequence as I've programmed. And it's completely adjustable, and I can do that at any time. One thing that I wanted to mention as well was the hourly fuel consumption. This graph here shows the fuel consumption relative to engine RPM, which inevitably leads to thrust, but we'll talk about that in a sec. But you can see that in the turbojet or any gas turbine engine, the fuel consumption along with the thrust is an exponential curve. It's not a linear curve like most piston engines are. So when we start low RPM, say idle, you're a little over 300 liters per hour. But once you start really giving it full throttle, you'll get up to 1,250 liters per hour. That works out to about 5 gallons a minute. So imagine you've got a 5-gallon pail or a nearly 20-liter fuel jug, and it's gone in a minute. So in some of the videos you see we run out of fuel, that's why. It consumes it real fast. Okay, now into engine thrust. If you look at this diagram, the engine thrust diagram, it's not producing a whole heck of a lot. The graph is in kilograms force. I think that's what the F is. So it starts at 100. So at idle, you're making a couple 100 pounds of thrust, which is nothing really. It's uncomfortable to walk behind it, walk 10 feet behind it when it's idling. It will blow hats off, earmuffs off, whatever. And then as the thrust increases, so does the, well, when the RPM increases, so does the thrust. So, 13 to 14,000 RPM, she really starts to climb, and then at full max 16,000 RPM, you're a little over 1,000 kilograms. Basically, you're up to that 2,400 pounds of thrust. So that's the graph of the power that it makes. So pretty cool. Thought I'd share that. Well, now that you've seen this in its current state, why don't we try to go back to some videos and clips of when we first got it. This was pre putting YouTube together, pre having any plan to, I guess do anything with it like this. So it might be a little clunky. I'll try to make it neat. Okay, that fucking lit off. I shut it down. We have quite a few fuel leaks here to figure out. But it was spraying hard out of this seal here and wrapped around the intake. And I thought, you know what? Probably not a great idea. So, shut down. I think we got to a 4,500 RPM. All right, until next time, thanks for watching.